Today I discuss about the solution of some hyperbolic equation. Suppose question given, solve cos z equal to 5. So how to solve it? How to extract the values of z? For this, we can write cos z can be written as z equal to x plus iy, which equal to 5. So here we use the formula of cos a plus b. So which equal to cos a cos x cos of iy minus sin x into sin of iy equal to 5. So for this we can write cos x. So cos iy is same as cos hyperbolic y minus sin x. So which equal to I sin hyperbolic y equal to 5. So for this we can write which is same as cos x into cos hyperbolic y minus I sin x into sin of hyperbolic y equal to 5. So on equating the real part and imaginary part, equating the real part and the imaginary part on both sides, on both sides we get. So here this 5 can be written as 5 in plus 0 into I. So if you equate the real part and imaginary part, you get cos x into cos hyperbolic y equal to 5 is one equation, is first equation, and in second equation just imaginary part will be equate imaginary part. So this is the imaginary part which equal to 0. So here we get sin x into sin hyperbolic y equal to 0. That is question number 2. So two equation given, equation 1 and equation 2. From this we can extract the values of x and y. So how to extract the values of x and y, we discuss it. So from this we get two equations. So which equal to first equation is cos x into cos hyperbolic y equal to 5, and second equation is sin x into sin hyperbolic y equal to 0. This is our equation 1. This is our equation number 2. So from equation 2 we get we get either sin x equal to 0 or sine of hyperbolic y equal to 0. So if you solve sin x equal to 0, then x equal to 0 plus minus 2n pi. Okay, so uh, here we never consider x equal to n pi, because in general solution is to obtain the fundamental period of sin x, that is 2 pi. So here x equal to plus minus 2 pi. If you consider sin hyperbolic y equal to 0, we get y equal to 0. So here we get two values x and y, and substitute in equation 1 which one is the appropriate in the present situation. If you substitute y equal to 0, so this one is, if you substitute y equal to 0 in equation 1, what happened? So if you substitute y equal to 0 in equation 1, we get x equal to x into cos x into cos hyperbolic 0 equal to 5. This implies cos x equal to 5. So here x equal to cos inverse 5, which is not possible because so cos value cos x and sin x, the maximum value is 1. So this one is not possible. Y equal to 0 is not possible in the present situation. So for this, so x equal to plus minus n pi is taken into consideration. So always remember, if sin x equal to 0, then x equal to 0, uh, then x equal to 0, 0 plus minus the period of sin x is 2 pi. So write in general form, that is 2 n pi. So if you substitute x equal to 2n plus 2 plus minus 2n pi in equation 1. Now now substitute now substitute now substitute x equal to plus minus 2n pi in equation 1. We get we get cos of plus minus 2n pi into cos hyperbolic y equal to 5. So this value is same as cos of plus minus observed, because cos of minus theta is cos theta. So this gives us 2n pi cos of hyperbolic y equal to 5. So from this we get, this implies a cos of 2n pi, this value is minus 1 to the power 2n into cos of hyperbolic y equal to 5. So this value is always positive, minus 1 raising power is positive. So cos of hyperbolic y equal to 5. This implies y equal to cos inverse hyperbolic inverse of 5. So the general solution, so we get z equal to x plus iy, and x value is plus minus 2n pi plus I. Y value is cos inverse cos cos hyperbolic inverse of 5. This one is our answer. Okay, so please subscribe for more videos. So in this way, we obtain our result. So for more video, to subscribe these channels for more updates. Thank you for watching.